A uniform gravitational field exerts a force of 45 newtons on a 1.6 kilogram mass away from point B toward point A. Okay, well, this is easy, right? So away from B toward A. Okay, A must be below B. Okay, because it's toward A, right? A must be below because the force of gravity is down. Okay, and then this is 23.1 meters. I'm going to make the up direction positive, down negative. And we'll make that positive 23 meters right there. Okay. What is the magnitude and direction of the gravitational field strength? So G is the opposite of the change in gravitational potential over change in R, right? But it's also, by the way, G is just force divided by mass. So let's do that. So 45 newtons, right? I'm going to make that negative, divided by 1.6. And the reason it's negative is that the force is down, and I made the toward A negative. So that's why it's negative. So negative 45 divided by 1.6 gives me a field strength of 28.125 newtons per kilogram. And that's toward A, okay? I'll put that in parentheses so it's not like a contradiction. It's a restating of the minus sign. Okay, so let's see. So what is the, okay, we did this. So we found the gravity. What is the change in potential if we move from B to A? Ooh, the change in potential. Okay, so now we can use this guy here, right? So our change in gravitational potential will be the opposite of G times delta R. Okay, so let's do this. So the opposite of G is negative 28.125, right? And we're going from B to A. And I'm using this system here, right? So we're going this way, down 23.1 meters. The field strength, the gravity is toward A, that's why it's negative. This minus comes from the formula, right? Okay, and then our displacement is minus 23.1. So that minus sign comes from, we went down, we're going from B to A, which in our system would be going negative 23.1, right? Okay, I'm just trying to be consistent here. Sorry about that. Okay, so that times, and I'm getting that our change in gravitational potential is negative 649.68, so I'll say 650 decimal point joules per kilogram. Okay, so let's see. If A, let's see, is it an increase or a decrease? It's a decrease. That's why the minus sign is on there. Okay, so let's see if we move from A. If A is at a potential of 154 joules per kilogram, what's the potential here? Okay, well, so if we went down, when we decreased by 650, if we went back up, it would be a positive 650. So I'm just going to add the 154 to the 650, right? Does that make sense? Let's do it. And I get 804 is my increase here. Okay, so where are we? Let's see. Oh, what is the change in potential if we move from there? What would be the change in potential energy if we remove the mass? Oops. Okay. I was answering the last question. I'm ready to answer it, but hold on. Let's do this one. Okay, so we're going to move the mass. Well, okay, so the work is just going to be mass change in VG. This is our change in VG, right? So it's going to be, what mass is it? 1.6 kilograms times negative 649.6875. That's this number unrounded, right? Okay, so 1.6 times that guy we'd go down. Our change in gravitational potential energy would be 1,039.5 joules, and that would be a decrease of potential energy, right? Okay, and then the question is, if A is at 154 joules per kilogram, what would B be at, right? Well, B would be 650 joules per kilogram higher. Okay, so it's going to be 154 plus 650, right? Would be 804 joules per kilogram. Is that right? 154 plus 650. Essentially 804 joules per kilogram at point B. There we go. Looks like peanut butter. All right. I hope that helps.